Welcome back. Today we are going through lesson 5.5, which is all about solving inequalities with two variables. So this is a review of graphing inequalities with linear and quadratic functions so that we can, in the next lesson, solve systems of inequalities. So for a linear function here, a linear inequality, we are going to graph that inequality with a boundary line and then find the region that represents all the solutions. So the first thing we do here is we graph the inequality and determine the type of boundary line. So we know the type of boundary line based on the symbol that is in there. So if it's greater than or less than, we use a dashed line. If it's less than or equal to or greater than or equal to, it's solid. So if it has the equal to, it is solid. So this function that we have right here, we know that the y-intercept of that equation is 0, -3. And we know that our slope is 3/4. So I'm going to use that to make my line. So here's -3. I'm going to go up 3/4. And you can do that a couple times to get a feel for what the line looks like. You can also go backwards 3/4. And for this one, I can see that it has a greater than symbol. So I am going to do a dashed line through those points. And then the second step, so we've got what the equation would be, but now to get the inequality, we need the boundary or the region that represents all the solutions, things that make the inequality true. So we're going to pick a test point to plug in and see if it makes something that's true, in which case we should shade towards that point, or if it makes something false, in which case we should shade away from it. So 0, 0 is generally a good point unless your line goes through 0, 0. So if I'm going to plug in 0, 0 as my test point, that means I'm going to have 0 is greater than 3/4 times 0 minus 3. So I'm just replacing the x and the y in my original inequality with zeros. When I simplify that, I get 0 minus 3. So 0 is greater than -3. That is true. And that means that I am going to shade towards that point. So if I go back up to my graph here, it means that this point 0, 0 is a solution. So I am going to shade this region that goes through 0, 0. So all of these points in this shaded region are solutions to the inequality. Anything in the white region is not a solution. We're going to do another example, but this time we are going to look at a quadratic function. This quadratic function is in vertex form, which helps me to identify what this quadratic parabola looks like, and then I can decide on my boundary line and shading after that. So the first thing I know is that it has a shift right 4. The second thing I know is that it has a shift up 5. So that means that I have my vertex at 4, 5 on my graph. And the other thing I see is that negative out in front, which means it has a reflection across. So that means that it from there is going downward. So it looks something like this. And again, this is a sketch. This one, this function, that wasn't a great parabola, but you get the idea, has the equal to with it, so that's why it's a solid line. So my boundary is solid. The last thing I need to do is pick that test point and decide if I'm shading towards that test point or away. So again, my parabola does not go through 0, 0, so I'm going to use that as my test point. So plugging that in, I have 0 is less than or equal to -0 minus 4 squared plus 5. Simplifying there, I would get -16 plus 5 and -16 plus 5 is -11. And so right now it says 0 is less than or equal to -11. That is false. That is not true. So that means that I'm going to shade away from 0, 0. So in looking at my parabola here, 0, 0 is on the outside of my parabola, if we think about it as a U. So that means that I am going to shade the inside of my parabola. So everything in that shaded region is a solution to the inequality. Anything outside is not. All right. The other thing I need to be able to do is I need to be able to write the inequality given a graph. So we're going to go through the steps to do that. So here we have a graph. It is clearly a linear function. Some key points that I can figure out about it. I can see that the y-intercept is at 0, 1. So that y-intercept there. And if I look, I can see that my slope is going down 2 over 1. So that tells me that my slope is -2. And that means that my boundary line is -2x plus 1. Now we have to determine that inequality sign. So I can see that it is shaded below the line. So if it's shaded below, that tells me that I have a less than or a less than or equal to going on. And then I look at the line itself. It is a dashed line. And when I have a dashed line, that means that it is just less than, not equal to. So that gives me the inequality. Y is less than -2x plus 1. So we take that equation and turn it into an inequality based on the type of line and the shading that's going on. We want to test a point just to make sure we did it right. So again, I'm going to test 0, 0 in this inequality and make sure that it makes a true statement. If it doesn't, that means that I need to flip my symbol. So simplifying here, I have 0 plus 1. 0 is less than 1. That is true. So we have the right symbol in there. Okay, we are going to move on to some practice here. So these first few practice problems are going to be graphing the inequality again. So for this first one, I can see that its y-intercept is at 0, -7. And the slope that they're giving us is 2/3. So I'm going to graph that line starting at -7, going up 2 over 3, making that line. And then I look at this inequality symbol. It has an equal to, so that means I'm going to draw a straight line through those points. And then I'm going to test my point. So I would have 0 is less than or equal to 2/3 times 0 minus 7. That would come out to 0 is less than 0 minus 7. And if I simplify that, it says 0 is less than -7. That is false. So that means I'm going to shade away from 0, 0, which means I'm shading on the other side of this line. So that would be my inequality there. All right, for our next one, I can see that this is a line with only an x in it, so that means it has no y-intercept. It never crosses the y-axis. So it goes through x of -4, and it goes straight up and down. So any point with an x value of -4 is a solution there. So then I look at my symbol. It is just greater than, so I am going to do a dashed line through those points, going straight up and down. And then again, I can test the point 0, 0. 0 is greater than -4. That is true. So I'm going to shade towards 0, 0, which means I'm shading this side of the line. Okay, looking at some more practice problems here. We have number 3. And in number 3, I can see that my equation is in standard form, not slope-intercept form. So I'm going to think about a different graphing method here. For this one, since it's in standard form, I'm going to find my x and y-intercept to start. So we should know that to find the y-intercept, we plug in 0 for x. So that means this is 0 plus 4y is less than 20. That means that my y-intercept is at 5. So I know that my y-intercept is 5. I'm going to do the same thing for the x's. So plugging in 0 for y, we get negative 5x equals 20. And then I would know that my x-intercept is at negative 4. So since it's in standard form, I found my x and y-intercept because that's easier. Plot those and then make my graph. So for this one, the graph would look like this. So you can see there, the x-intercept at 5, or sorry, the y-intercept at 5, the x-intercept at negative 4. It's a dashed line because it's just less than. And when I test 0, 0, I would get 0 is less than 20, which is true. So I would shade towards 0, 0. Okay, number 4 here. Number 4 is also in standard form. And again, we can use different graphing methods. You can choose whatever you want. So another one we can do when it's in standard form is we can rearrange it into slope-intercept. So I could also solve this inequality for the y value, which would look like this. Remember that when you divide by a negative on both sides, you have to flip that symbol around. So we just want to be careful there that we do that. So now I could plot my negative 4, and I could do my slope of 1. So start at negative 4, go up 1 over 1. And then I could test 0, 0 here. This would say that 0 is less than or equal to negative 4. That is false. So I would shade away from 0, 0, and I would get a graph that looks like this. So you can see that negative 4 going up 1 over 1, and then shading away from the 0, 0. All right, number 5. Number 5 is a quadratic. I see that squared. So I know that the vertex is at negative 3, negative 6. So for this one, to get an idea of what my graph is going to look like, I'm going to plot that vertex point. I know that one. And then I'm just going to find some points around it. So if I plug in a negative 4 for the x value, I would get an output, and again, you can use your calculator to do this, do it in your head, whatever you need. I would get an output of negative 5.5. That means, remember, because of symmetry, that negative 2 would have the same x value. So that gives me an idea of kind of where my parabola is going. You could do some other points, like if I plug in negative 1, I get out a 4. And if I plug in 0, I get out 1.5. So that gives me some points to plot. So I could plot those points, connect them. It looks like I have a greater than symbol here, which means I'm going to connect them with a dashed line. And then I'm just going to check. If I plug in 0, remember we already kind of did this. When we plug in 0, we get out negative 1.5. And we know that 0 is greater than negative 1.5. So that means I'm going to pull or shade towards 0, 0. So that's what my parabola would look like. All right, number 6 here. So for number 6, this one is not in vertex form. This one's in factored form, or sometimes we call it intercept form. Because of the way it's written, I know that my x-intercepts are at 1, 0 and 2, 0. So that helps me to kind of find some key points. Again, you can make a table for some more points to make sure you kind of know. So I know 2 and 1. Maybe I'll pick a point bigger than 2. So if I plug in 3, I would get out a 4. And then maybe some points smaller than 1. So if I plug in 0, that would give out a 4 as well. And maybe one more point if it's helpful. If I plug in negative 1, I would get out a 12. So now I've got 5 key points that I can graph. I can plot those. It is less than or equal to. That tells me that it's going to be a solid line that I'm going to use. And then I would just test if I plug in 0, 0 for my x and y. I know that I get out 4 on this side. So this says 0 is less than or equal to 4. That is true. So again, I am going to shade towards 0, 0. So that would be the outside of the parabola. So that's what that one would look like. Okay, our last two examples here are all about graphing, or given a graph of an inequality, writing the equation. So for this first one, I can see that my line is a horizontal line, and it's going through the y value of -2. So my line is y equals -2. And then I can see that it's a solid line. And I can see that it is shaded below the line. So because of those two things, that's less than or equal to. So my inequality is going to be y is less than or equal to -2. And lastly, for number 8, we have a line here. I can see that the y-intercept is at -2. And then if I look at my slope, it goes up 1/5. So that means that my slope is 1/5. So my equation would be y equals 1/5 x minus 2. And then I check for my other two parts. I can see that it is a dashed line and it is shaded above. So that means that I am using the greater than symbol. So my final inequality is y is greater than 1/5 x minus 2. All right, that's all for today. We'll see you next time.